Okay, a hot plate on an electric cooker contains two identical resistors. That means their resistance are exactly the same. Now, the switch has three positions. The first position, the two resistors are connected in series. So I quickly just draw a diagram. The second one is they are connected in parallel. So this is switch 2, position 2, and this is position 1. And position 3, there's only one resistor. Can I ask, out of 1, 2, and 3, which one has the highest resistance? Highest resistance. Which one has the lowest resistance? 2. The third one has middle lah. Okay. So how do we test? We can put in numbers. 2 and 2. What's the effective resistance? 4. Of course, we must keep the values the same, right? 2 and 2, the effective resistance is 1. 1 only is 2 ohm. So I already proven to you that in series highest resistance, parallel lowest resistance, right? Then the third one, because there's only one resistor, so the effective resistance is 2 ohm. Okay. Now they are asking us which one has the highest power setting. Highest power setting. So I will be using P equals to V squared over R. Because I have resistance, correct? And if I were to plug into the mains, the V will be the same, 240 volts, right? The mains will be the same. It delivers or it has a potential difference of 240 volts. So with this, and I don't even need to put in the value of V. Now V squared is going to be divided by your R. So if my R is max, I'm going to be dividing a V squared by max value of R. My P will then be minimum, right? P will be lowest, right? So which one has the highest R? 1. Then we do the high power lah. When will we have high power? Again, P equals to V squared over R. Okay, the V is going to be constant. The R is going to be the lowest. R lowest, right? Because the V squared divided by a lowest number will give a maximum number. Right? Math, you are dividing by something that's very, very low. In the end, you'll get something maximum. So this will then be 2. Okay? So B will be the answer. But some students may think, oh, I use P equals to IV. I find V equals to IR. Okay? The one with the maximum resistance is going to give the minimum current. Maximum resistance will have minimum current, right? That is true. Correct? But this V does not tell me about the power. To find power, you have to use P equals to IV or P equals to V squared R, which in this case is the most direct. Okay? Remember, we have 3 formulas for power. P equals to IV, P equals to V squared over R, and P equals to I squared R. Okay? Because the resistance will change the amount of current. That's why I don't use this and I don't use this. Huh? Can I explain again? Because you see, if I use a fixed amount of voltage, which when I plug into the mains, I get a fixed amount of voltage, right? But because the R is different, the I will be different. If the I is different, then when they multiply by P equals IV, I will then get my power. So I have to do a 2-step thing. I have to first find the current, then I have to find the power by using P equals IV. Yes, just like yesterday, you also like to do the 2-step. But for me, I know you will still get the answer. Mika will still get the answer, even though he used 2-step. That means he find P equals IR to find the current first. Then after that, he substitute into P equals IV. He will also get the same answer, right? but that involves 2 steps. But for me, I know the V will not change. The V don't change, right? For all three cases, the V is the same, but the R changes. And I know if I have maximum R, my P will then be minimum. Anyone needs me to repeat? Okay, so the next practical electricity question is found in page 31, question 19. A 2 kilowatt aircon is used for 4 hours. So 2 kilowatt, I'm not sure whether you have annotated it, but this is PAC, power rating of aircon. Because later on there will be another power. 4 hours, I can put it as TAC. Okay, TAC, just to set it apart from the fan, which is PF. Power of fan is 80 watts. They are asking for how long will it take for the ceiling fan to use the same amount of energy. So this time I will put it as TF. Okay, so just to set them apart from each other. Alright. So yes, PF power of fan. TF is time of fan. Okay. Are we comparing 2 items? Fan versus aircon. What is common between them? The same amount of energy. I try to sell you all this method for a very long time already. When we compare between 2 scenarios, 2 cases, we find out what is common between them. What is common between them? So can I say EF equals to EAC? Energy used by fan is equals to energy used by aircon. So what is the next step? So I found out what is common between them. I change it into the formula in terms of energy. So energy of fan will be PF TF, correct? PAC and TAC. Yes? Do we have all this in the question? Yes. Suddenly the solution becomes very simple. We identify what is common between them. Anytime they ask us to compare between 2 scenarios, we find out what is common between them. Okay? And once we find out what is common between them, we transform them into their respective formula. And if you have annotated it, the answer will be presented to you. Okay? So PF is 2000. PF is 80. I heard a zip. PAC is 2000. TAC is 4 hours. Do I need to change my TAC to seconds? Why? Because you look at all the options, they are in hours. So we don't waste time to change it to seconds. Because after you change to seconds, we get the TF in seconds, we have to change it back to hours. Correct? So no need. So when we have this, answer will be how much? 100 hours. Simple. What is the trick? What is the trick for this question? Page 48, question 15. What is the trick? You don't take, you have to change hour to seconds. Then final answer, of course, kilojoules, right? Divide by 1000 for your final answer. So are we okay with this question? If okay, we skip. Next question. How do you know it's practical electricity question? When we see money. So this is 1 kWh. 1 kW. So this kW is the unit for kW. Is the unit for power. H is the unit for time. So actually this is equal to energy. Okay. So for when you see money involved, you always need to convert your power to be in kW. It's a must. When you see that it involves money, it is practical electricity, your time must definitely be in hours. So I have 60 watts. What do I need to do? 10 hours, anything need to change? No need. But this question very simple. They didn't tell us how many weeks, how many days. But sometimes you need to take note. Sometimes they say, what happens if I use this lamp for 2 weeks? Every day I use it this number for 10 hours for 2 weeks. Then you really need to read the question. Okay? Sometimes they say, what if I use this lamp? I use 2 of the similar lamps. Then you need to times 2. Okay, that's how we can add variation to the question. If not, this one very simple. Can I? Okay, for this question, how are the resistors connected? They are connected in parallel. In parallel, what is common? What is same? Parallel means same voltage, same voltage. They are asking for how much energy. Energy is actually power times time, right? Do they all use the same timing? Are they all turned on and used for the same time? So the T is 2 minutes. 2 minutes, you know, you should definitely either change it to hours or second. Do we see money or dollar sign? No, then straight away change it to seconds. If you see money sign, you must change it to hours. You don't see money sign, minutes, confirm cannot one. You must change it to seconds. Sorry? So, for this resistor R, what do we know about resistor R? So, RR is 24 ohm. How about the voltage? Do we know? VR, right? We know is 110. Now, if I want to calculate power, how would you do it, Mika? If I want to find power, what's the formula that you memorize? P equals to? P equals to? E over T, But I first need to find E lah. But then, how can we find power using V and R? V square over R, right? Or can I calculate power to be IV? Can, right? Then after that, but I only have V and R here. So I will need an additional step to find the I first, right? Yes. But if I have V and R, I can instead use P equals to V square over R. So although these 3 power formula, they are the same thing, they will give you the same answer eventually. Then you think, oh, maybe I should just memorize P equals IV lah. Why need to go and do all this? But if you are able to memorize the other 2, they can shorten your working. Okay, so let us do for R, 110 square over 24. Okay, I just leave it like that. How about for S? What do we know about resistor S? We know Vs, right? We know Rs, correct? So similarly, Ps yes, 110 square over 48. Okay or not? I'm using the V square over R. But if you're going to use P equals IV, you find your I first. But then when we come to T, we don't know its resistance. What do we know about T? We know IT. Current of T is 0.8. We know VT because in a parallel, voltage is the same. So we know VT and IT. So then we use PT to be equals to IV. We just use what we know. Why don't we use V square over R? Because we do not know the R. Can we calculate the R? Can, because we have V, we have I, we can calculate the resistance. But that will involve me taking one more step, right? So I work with whatever I have. I have V, straight away I use my P equals to IV. Okay? But of course, during exam, sometimes you may not think so deeply. You just go with your gut feeling, use V equals IR, use P equals IV. It's okay. Eventually, you'll get the same answer. Okay? So PT equals to IV. So this is equals to 0.8 times 110. So I add up all their power together. And then eventually I use E equals to PT. I take this P is PR plus PS plus PT. Because they are all going to be multiplied by 120 seconds, right? So might as well I just add up. I bring out the T. I just add up all the power. Then one shot, I multiply it by 120 seconds. Do you need any clarification? Now, a fuse is, page 128, a fuse is connected to the neutral wire of a fan. Is this the right way to do it? No. 126, it is connected to the neutral wire. So this presents an error. The fuse, switch, circuit breaker, all connected to light. Okay, so which of the following statements are correct? So if it's correct, I put a T to say it's true. It's wrong, I put a false. So the fan will not operate if the fuse blows. True or false? True. I show you. That's a fan. So I got live and neutral. Now you see that the fuse is connected to neutral. Yes? Are you all drawing this? Live connected to neutral. So when the fuse blow, according to 1, the fuse blow. I know the fuse is in the wrong position, but it's already been connected. Let it be. But if the fuse blow, what will it create? Open circuit, can the current still flow? Cannot. So the fan will not operate. This is true. This is true. The fan will be safe to touch when the fuse blow. False. Danger. No. It was, you see, I create an open circuit, right? Is the fan still connected to the light? Yes, and that is dangerous. So that is false. Statement 2 is false. All okay? The fan will still be connected to the high voltage source when the fuse blow? True. So 1 and 3, answer is B. I think this one also put a star. Okay, put a star. They are asking for correct statement for wave. Longitudinal wave, can it travel through a vacuum? False. Longitudinal waves cannot transfer energy. False. They transfer energy. Transverse wave travel at the same speed in a vacuum. True. False. Because this is talking about transverse wave. Water wave is also transverse wave, so it's false. Transverse wave have vibration at right angles to the direction. True. So answer is D. What is C? False. Transverse wave can be water wave, right? Transverse wave can be rope wave. I use a rope, I swing it up and down. Yes, I can swing it in vacuum. What will be different? Okay, speed is different. So obviously this is an echo question. Okay, a ship that's stationary on the surface of the sea sends pulses of sound vertically downwards towards the seabed. Did you all draw this simple diagram? Now each pulse that reflects from the seabed is received 1 second after it is sent out. it is received 1 second after it's sent out. Go. It goes down. 1 second later, it comes back. So going down takes how long? 0.5 seconds. And that is the purpose I wanted you all to draw this diagram. So you can identify whether the timing or the distance is it one way or two way. So one way going down is 0.5 seconds. One way coming up is also 0.5 seconds. Now a school of fish swims under the boat and a pulse is received 0.6 seconds. So now I'm going to draw the fish. So one way going down takes how long? 0.3. It takes 0.3 to hit the fish and takes 0.3 to come back up. .3 seconds. Now, speed of sound in seawater is 1500. So this is the V. What is the distance of the school of fish above the seabed? How do we do this? Above the seabed, you know, not below the ship. So what is the time difference? The time difference is actually just 0.2 seconds. One way. You see, if I go down all the way, I take 0.5 seconds. I go down to the fish, it's 0.3 seconds. So what is the time needed if I want to touch the fish and still go down? 0.2 seconds. Distance equals to speed times time. I will use this 0.2 seconds. And the speed, I will get the distance between fish and seabed. Okay? What kind of wave is this? Transverse, what do you think of? Okay, so besides perpendicular, you also need to know examples of transverse wave. So now, direction of propagation is to the right. So the direction of vibration of the particles must be perpendicular. So it's either B or D. Either B or D, but it's not that simple. If the wave is going to the right, what must we do? Actually, this question is good to jog back your memory. You need to draw the next wave. You need to draw the next wave. So, where you put a ruler at point P, where does it intersect the next wave? Below. So, answer is D. Okay, so